Okay. So again, welcome to our KIT 257 lecture. And before we continue from what we have, end yesterday, probably we can do a little bit of recap of what we have learned yesterday. So for yesterday, basically, I'm just referring to very few examples on binary eutectic samples from your additional notes. And I think apart from looking at or reading the phase diagram, I guess most of us now have been cleared with how you can actually calculate the mass fraction as well as the volume fraction. So the volume fraction that I think given in the examples that I put in the additional notes is quite essential, it's quite important. I really hope that you guys can understand and can, I think, digest it well. And in fact, yesterday I have also give some, I think, quiz just to see your understanding on, I think, binary eutectic phase diagram. Above all, I guess, referring to your quiz one, I think maybe some of you are, I think, doing well. You guys can understand the concept, basic concept of Hume rotary rules, and also the isomorphous phase diagram. But I guess maybe some are still struggling on understanding the basic concept of reading the isomorphous phase diagram. So for yesterday's quiz, I guess I have not go through. Maybe some of you just submit it today, and maybe later on I will check it, and maybe later on we can discuss. Right. Apart from the volume fractions that we have looked into yesterday, we also have looked into the microstructure of a eutectic system, and this, I think, I've also give you some homework to do. Okay, so in microstructures in eutectic system, we have a few regions that we need to understand. Okay, so of course the first region that I'm talking about is the region where you have like 0 to 2% of tin. Okay, and this is actually the thing, because over here you can see that the solidus line of alpha actually goes, or it bends down till a very small value, and this value is approximately around 2% of tin. Okay, so in between, if let's say that you are going to have a phase or formation of alloys at different temperature, for example, around 1% of tin, you have at around 330, 350 over here, okay, which is actually equivalent to liquid phase, okay, then you will have a microstructure as this. And if you have, I think, a phase at around 330, for example, okay, you will see that you have one point here, and this point is actually located in liquid plus alpha. Then you will have this microstructure. And if you have a phase that exists in alpha region, then you will have one phase which is alpha, and the formation of the microstructures will be the polycrystalline alpha. Okay, and the second region, of course, is in between 2% until 1.3, 18.3% of tin. So 18.3 is somewhere here. Okay, I just dotted this line. You will see that this is actually the line. Okay, so this is actually the range for this region. And basically, if we give an examples at around maybe 80%, C naught of 18%, or 70% of tin, and at different temperature, you will have a different variation of phases that you can get. For example, at higher temperature, you will get liquid. At around below 300, you will get liquid plus alpha, formation of alpha grains. And then at around 200, you will have alpha, formation of polycrystalline alpha. And then finally, if you have alpha plus beta, it still have a background of polycrystalline alpha with the formation of small dot or grains of beta. Okay, right. Let me just admit few peoples in. Right. And another region will be at eutectic composition. So imagine that if you have eutectic composition and you want to see the microstructure, there's only two possibilities, because this region you can have either in liquid and also alpha plus beta. So what would be the microstructure? For liquid, obviously it will be blank like this, and for alpha plus beta, it will, the formation of lamellar structure. Okay, so lamellar structure is actually like alternating contrast color. Okay, so you can see from the electron microscope is, the shape is like a pattern of a zebra skin or something like that. So this is actually indicating that you have alternating arrangement of alpha, beta, something like that. And the formation of lamellar eutectic structure is actually due to the formation of different grains, okay, which cannot be mixed together. And what happened is that after the formation of one grains or one structure, then it will be followed by the formation of another species and followed with another species. So that is why you have like alternating or jumping formation. And finally, you can also have a region at between 18.3 until 61.9. This is actually the region. Okay. So the possible microstructure over here, you can have either liquid structure at higher temperature. Okay, at around below 300, you can have liquid plus alpha, formation of still alpha grains. And then after that, towards the eutectic temperature, you can see that the formation of this alpha grain become bigger. And when it goes into alpha plus beta region, you can see that it forms a lamellar structure with the formation of primary primary alpha. Okay, all right. So that will be some examples. And I think yesterday also I give you one situation. Imagine that if you have a region between 61.9 until maybe 97.8. Okay, so what would be the microstructure? Okay, imagine that I ask a question around C naught is equals to 80%. So the microstructure will resemble almost the same as what we are looking at this range now, except that when you have alpha plus beta, okay, for example here, then this will be, I think, still the formation of lamellar structure. Okay, you still have a lamellar structure. Okay. But now maybe you have like one or a few bigger grains which actually equivalent to primary beta, no longer primary alpha. And talking about primary alpha and primary beta, so this is what we have discussed also yesterday regarding on hypoeutectic and hypereutectic. So what does it mean by hypoeutectic? Hypoeutectic, it means that you have a more composition of alpha and I think very less composition of beta. Meanwhile, for hypereutectic, it means that you have more composition of beta and less composition of alpha. Okay. Right. So today we are going to continue, okay, with a term known as intermetallic compound. So what does it mean by intermetallic compound? Okay, so before we go into the definition, let me just briefly tell you how does the intermetallic compound can form. So imagine that if you have one substrate, uh, like for example a metal, okay, and then you have your soldering materials. Soldering materials, for example, over here is PBSN, okay, lead tin, and when you apply heat, okay, or when you do flux, probably you do some soldering process. So what will happen is that you'll see that the layer now, okay, on top will be covered with your soldering material because it's already melt at a lower temperature, and you have some elements or some materials that penetrate inside, okay, the substrate. Okay, so this actually been infused into the substrate due to heating process, and this one we call it as intermetallic compound, IMC. Okay, so IMC or intermetallic compound is actually intermediate phases when the amount of solute element is more than the limit of solid solubility. A second phase also appears apart from the primary solid solution. Okay. Intermetallic compound form at the intermediate composition between the two primary components. Okay. So in this case, if I'm talking about you have this two materials together, you have like soldering materials and one substrate over here, then you know that this is actually a two primary components. Then the intermediate that forms in between due to the flux process or due to the heating process, due to the infused process, is actually forming in between uh, the material. The crystal structure is different from both primary components. Okay, so when we talk about the crystal structure, obviously you know that this one can be justified using XRD, X-ray diffraction techniques. Okay, so from here, when you do the XRD on top of the layer, you will see the profile for lead tin materials is different with your substrate. For example, your substrate here is copper. Okay, we will give a different crystal structure. And if you take some, or maybe if you just beam the X-ray over here at the intermediate region, you will see the crystal structure also behave differently. Okay, so intermetallic compound actually forms at the fixed composition of the intermediate phases. Right. So how to identify the formation of intermetallic compound or intermediates when you have a phase diagram? So over here, this is actually an example of magnesium lead phase diagram. Okay, so what you can detect over here is that you have eutectic reaction. Okay, so how I can actually identify there is a eutectic reaction, because I can see there's one horizontal line over here. Okay, so when you see one horizontal line over here, just check what will be the top. The top of this line is actually liquid, and the bottom of the line is actually the two solid. So the eutectic reaction for this phase diagram will be liquid over double arrow. Okay, formation of alpha plus magnesium to lead. So this is actually the eutectic reaction. But this is actually not the intermetallic compound, um, I think, range. Well, actually, the intermetallic compound can be seen if you have a vertical line like this. Okay. So this actually indicates that you have intermetallic compound. So apart from the terms of intermetallic compound, some textbook they just use it as congruent. Okay, congruent. So congruent actually indicates that you have intermetallic compound, right? So I guess a few years back, I give one exam question, one phase diagram that has a multiple reaction, and I ask the student to identify what will be the reactions and everything that may present. So a part of that, I mentioned about congruent, and they just like questioning themselves, what is actually congruent? Congruent, to tell you the truth, is actually the intermetallic compound. So make sure that you memorize that. Okay. All right. So as I said, the intermetallic compound actually can be indicated when you have one vertical line like this. So this is actually formation of Mg2Pb, a sole material of magnesium lead. Okay. And if I think someone asks you what will be the composition that may form the intermetallic compound, okay, for this phase diagram, it can be seen that it will form the intermetallic compound at around 80% of lead. Okay. Okay. So far, is there any question? Anything that you would like to ask before we continue with another phase diagram? Any question? All right. So if there's no question, then I will proceed with another phase diagram. So far we have looked into two types or maybe three types of phase diagram. The first one, isomorphous, binary isomorphous. Second one, binary eutectic. Third one, maybe on intermetallic compound, but this is actually not thing really much been discussed. We just identify where does this intermetallic compound form, and then how it is possible to be formed, definition and everything. And today we are also going to look at another phase diagram, which is quite important, a cast iron phase diagram, or iron carbon, FEC phase diagram. Okay, so this is basically a very popular phase diagram. It's just to indicate that when you work with materials, so part of the important materials will be cast iron. So it is also important to understand the phase diagram or the behavior of the cast iron. So basically, if you see the formation of um, iron carbon phase diagram or cast iron phase diagram, it is completely different pattern with binary eutectic. Okay, and obviously you can see that over here you have a multiple or at least two types of reaction that occurs. Okay, so the first one, okay, that may be related with what we have studied earlier is actually eutectic. Okay, so what does it mean by eutectic? Again, maybe I can ask someone the definition again about eutectic. Siapa-siapa yang boleh jawab? Fatin Fakihah, ada tak? Fatin Fakihah? Tak ada? Okey. Fatin Nurdini. Dua-dua Fatin tak ada. Ada?
Ya.
Ada. Okey. Fatin, what does it mean by eutectic?
Eutectic contains two solid phase.
Sorry again?
Contains two solid phase at low temperature.
Okay. So what about the reaction?
Reaction.
How can you define eutectic in terms of the reaction? Apa, macam mana kita nak buktikan kita cakap eutectic tu sebenarnya dia bermaksud apa? Okay, so the same thing macam saya beritahu tadi. I think if you want to identify eutectic is by looking at, okay, you have a horizontal line macam ni, and then you see what will be the top. Liquid, and then at the side of this line, you have austenite and also cementite. So this is actually, the whole thing is actually cementite. So dua-dua ni solid. So to define eutectic is basically, eutectic means that when you have one solid, okay, one liquid, this liquid when you cool it, it will form two solid. Okay, it will form solid 1 plus solid 2. Okay, so in this iron carbon phase diagram, okay, macam tadi, I think for binary eutectic, we have seen the eutectic reaction will be liquid, double head arrow, alpha plus beta. So this is actually reaction for eutectic, and probably for lead tin phase diagram, maybe we use the term alpha beta. But now the similar concept, one liquid, when you solidify, it forms another two solid, but now the solid will be different. You have liquid, double head arrow, gamma plus Fe3C. Gamma is actually austenite and Fe3C is actually cementite. Okay, so this is actually eutectic. So betul lah macam Fatin tadi cakap, eutectic actually means metal or alloys that melt at a lower temperature. So this is actually part of the requirement. And for iron carbon phase diagram, there will be additional reaction that you are going to see. Okay, still we are looking at the horizontal line over here. Okay, and this horizontal line, the top one, okay, you see there's like a, apa tu, kita cakap intersection of liquidous line. Okay, top kita nampak gamma or the solid, and the end kita nampak dekat hujung ni is actually ferrite and also cementite. So this reaction is actually known as eutectoid. Okay, eutectoid reaction actually defined as if you have one solid, okay, this solid when it cools, okay, it forms another two solid. Okay, so in this case, gamma, when you solidify it, it will solidify to form alpha or ferrite plus with cementite, Fe3C. Okay, so macam mana saya nampak ni? As I said, okay, you will see one horizontal line. The top of the horizontal line will be the reactant, okay, gamma. Okay, dekat atas ni nampak gamma. And then at the side, okay, hujung line tersebut, you will see alpha and also cementite. Okay, so this is actually known to be eutectoid reaction. And normally eutectoid reaction forms below, even lower than eutectic reaction in some cases. Okay, alright. So this is basically to explain the iron carbon phase diagram. So in iron carbon phase diagram, we have two important points. The first one is known as eutectic reaction. Okay, so the eutectic reaction, I think I have briefly show to you. This is actually the reaction. This is where the reaction occurs. And we also have eutectoid. So eutectoid that occurs over here. Again, for eutectic reaction, it means that you have one liquid that when it solidifies, it forms two solid. Meanwhile, for eutectoid, it means that you have one solid that when it cools, and when it solidifies, it forms another two solid. Okay, right. So eutectic, liquid transform into two solids. Eutectoid, one solid phase transform to another two solid phases. So this is actually what I have mentioned to you guys earlier lah. Okay, so for alpha beta, this is actually the examples that we are looking at for PBSN. Example, kita pakai PBSN. But if we are referring to iron carbon, we are not going to use alpha beta because for iron carbon phase diagram, alpha actually means different thing. It will means the ferrite, the one that have more iron, ferrite. Okay. So for iron carbon, we rather use gamma or austenite plus with cementite. Okay. So before we look into the things on I think hypoeutectoid and also hypereutectoid. Okay, maybe I can give you some examples. Kejap, Oh, maybe we look at the example first and the microstructure before the examples. Okay, so hypoeutectoid. Before this, in binary eutectic, we've heard about hypoeutectic and hypereutectic. So for hypoeutectoid, it actually means that the region at the below the range, normally it forms somewhere here. Nampak tak dekat sini? So it forms in between maybe 0.00 something until 0.7. Okay, so this is actually the region of hypoeutectoid. So hypoeutectoid, literally, it means that you have more ferrite, ferrite or alpha than cementite, Fe3C. Okay. So what would be the possible microstructures? Okay, imagine that if we are looking at this in this range, maybe at around 0.002, in between 0.77. Okay, so I give a few points over here. So there's a possibility that it forms solid austenite. You will see formation of polycrystalline gamma. And then when it enter this region, so this region is actually known to be gamma plus alpha. Okay. So you will see that in the grain boundaries, there's a formation of a small dot, which is actually equivalent to alpha. And going down to the temperature when it solidifies, this grain become continuously combined with each other to form like a root. Dia macam membentuk akar. Okay. So this one we call it as pro-eutectoid. Pro-eutectoid alpha. Okay. Pro-eutectoid alpha. Okay. So in eutectic, we say it as primary alpha. But in eutectoid system, we call it as pro-eutectoid because it has more alpha over here. Okay. And finally, when it actually goes into the region of alpha plus cementite, alpha plus Fe3C, then you will see that formation of lamellar structure with pro-eutectoid alpha. So this is actually the microstructure. Okay. Another region will be hypereutectoid steel structure. So this range actually at around 0.77 until perhaps 2.3, around that. So some possibility as well. Okay, you have different points over here. Gamma, formation of polycrystalline gamma. And when it enters over here, so the range over here is actually equals to gamma plus cementite. So you will see over here in the grain boundaries. So you will see the formation of cementite grains. And as it goes down, this grain will be combined with each other to form pro-eutectoid cementite, Fe3C. And when it enters to alpha plus cementite region, still the formation of lamellar structure and a root structure of pro-eutectoid cementite. Okay, all right. So before we go to the examples, yes, I think I forgot to tell you also one important things. Okay, for eutectic reaction, we know that this is actually the eutectic composition, right? So for FEC, this eutectic region is known to be Lamellar region, okay, or Lamellar phase. Meanwhile, for eutectoid region, so this is actually composition of eutectoid. This phase is known to be perlite. Perlite. So if the question asks you what would be the weight fraction of perlite form, so you know that perlite actually refers to composition of eutectoid over here, 0.77. Meanwhile, for lamellar, okay, this one is actually at around 4.3, for example, percent. Okay, right. So we are going to look at the examples. So for a 99.6% of iron, 0.4% of carbon still at temperature just below eutectoid, determine the following: the composition of cementite and also ferrite. B, the amount of cementite in grams that forms in 100 grams of steel. And C, the amount of perlite and pro-eutectoid ferrite in 100 grams. Okay, so we have a few question that asking about composition and also amount. But first, maybe we look at the phase diagram. Okay, so this is actually the phase diagram. The question asks at 0.4, because you know that this is actually 99.6% of iron and 0.4. Okay, so 0.4%. So 0.4 maybe somewhere here. Okay, this is actually 0.4. 0.4% carbon. So you just draw the vertical line. Okay, then after that, it says at the temperature just below eutectoid temperature. So where is the eutectoid temperature? Eutectoid temperature is over here, 727, not 1148. This one is actually temperature eutectic. This one is actually temperature eutectoid. Okay, so just below, maybe around 726 or 720, for example. Okay, so you have a point over here. Okay, nampak I circle the point here. Right. So first question, what will be the phase of this point? Maybe I put this as point A. What will be the phase of point A? Sekejap, saya tanya. Khalaf. Khalaf Hanafi. Oh, macam famous je nama Hanafi ni. Khalaf Hanafi ada?
Hello.
Hai Hanafi. Okay. Alright. So, what will be the phase for point A? Apa dia? Phase, dia punya fasa dia apa? Point A tu tadi saya beritahu. 0.4% of carbon at the temperature just below eutectoid temperature, maybe 720. So what will be the phase? Tak dengar, putus-putus. Apa dia? Kalau line tak clear mungkin boleh type kot ataupun Macam mana? Boleh dapat? Hanafi? Okay, I cannot hear you anything, but it's okay. I think at least you are trying to speak out. Li Jing? Li Jing, are you there? No, cannot hear anything from Liu Jing. Mardiana Zubir?
Hello?
Ya, okay. Mardiana,
Yeah,
apa dia punya fasa dia? Point A.
point A. Alpha plus cementite.
Okay, alright. So alpha plus cementite. Macam mana boleh tahu alpha plus cementite?
Because dia duduk dalam region yang alpha plus cementite.
Yes, correct. So you will see that it actually, I think, sit located in this region, alpha plus cementite. Okay, so we already know the phase. Phase is alpha plus cementite. So when you have alpha plus cementite region, it means that the composition that you need to report is basically alpha and also cementite. Okay, right. So if I ask another question, so what will be the composition of alpha and composition of cementite? If you read roughly from the phase diagram. Najwa Izani, ada tak? Najwa Izani? Tak ada. Okay. Navanidhan ada? I saw your mic is on, but I cannot hear anything from you. Nava? Okay. I think maybe some technical problem. Nick Muhammad Syafiq? Nick Muhammad Syafiq ada? Pun tak ada. Lenyap. Nur Ashikin binti Muhammad Rashid.
Yes, Doctor.
Okay, alright. Ada pun Ashikin. Okay, Ashikin. So tadi kita dah dapat dah dia punya phase alpha plus cementite. So now, as I told you, when we already identify the phase, so composition, we have to report both alpha and also cementite. So what will be the composition? Ada dah tu ditulis tu.
C alpha 0.02%.
Okay, 0.022%, and then cementite.
6.70.
Okay, yang ni memanglah dia dah tulis jawapan dah kat sini. But how actually you can know is that, as I brief in the previous class, you just drag the line until the solidus line of alpha. Nampak alpha ni kecil je dia punya ni region dekat sini. So you drag it down here, then you get composition of alpha. Meanwhile for cementite, so cementite dia sebenarnya dekat ujung ni. Dia tak nampak dia punya ni, but the whole vertical line is actually belongs to cementite. So you just drag the line, and this is actually the value for composition of cementite. So this is actually the two value. So what will be the next question? The next question is actually to identify the amount of cementite in grams that forms in 100 grams of steel. So yang ni soalan dia bagi dalam kuantiti 100 grams of austenite. Okay, so what will be the formation of ferrite and also cementite? Okay, so to answer this question, basically, once you have identified point A, the same thing, we apply the tie line. Okay, you have one over here is actually equals to R, and another line is actually equals to S. Okay, so the line that located from A until the solidus line of alpha, so this is actually R, and the line from A until cementite is actually S. Okay, so first we want to identify what will be the weight fractions of alpha or ferrite. Okay, so ferrite is actually located on your left hand side. The opposite line will be S lah. Okay, so S over R plus S. So S 6.7 minus with 0.4 divided by 6.7 minus with 0.022. Okay, and since this actually will result you a fraction, if you multiply with 100, because 100 grams, given is actually 100 grams, you will get the amount. Okay, so you will get the amount which is equal to what? I don't know. Dekat sini, if you deduct 1 minus 0.057, you will get some values, and this actually will result you the amount of ferrite that is formed in kilograms. Oh, sorry, not kilograms, in grams. Okay, and the question is actually asking what would be the formation or the mass of cementite. So we are looking at another one, WF3C. So cementite is actually located on your right hand side. The opposite line will be R over R plus S. So what is R? R is actually 0.4 minus with 0.022 divided by the tie line, 6.7 minus with 0.022 times with 100. Then you will get the amount of cementite that is formed is equals to 5.7 gram. So this is actually for cementite lah, but for ferrite it will be in opposite lah. So 100 minus with 5.7 grams, you will get maybe around I don't know 90 something, okay, of ferrite that forms. Okay. Right. The next question is actually asking about the amount of perlite and pro-eutectoid ferrite in 100 grams. So this one is actually special because when we talk about formation of perlite, so perlite tadi, I think as I briefed you earlier, where will be the composition that we are looking at now? Adriana ada tak? Adriana, Nur Adriana, Ahmad? Ada. Okay, so for perlite, what will be the composition that we are looking at now?
Alpha and gamma.
Alpha and gamma. Kat mana sebenarnya region untuk perlite ni? Okay, so if you recap back what I have said just now, perlite is actually forming at composition of eutectoid. Perlite ni dia terbentuk pada composition eutectoid. This is actually composition eutectoid. Nampak ni? Bentuk dia punya bucu ujung ni kan? So this is actually composition of eutectoid. Or this can be known or can be referred it as perlite. Keluar pula huruf E. Okay, so perlite is actually located here. Okay, so composition eutectic dekat sini, but composition eutectoid over here, and this is also can be referred as perlite. So now the story is slightly different. Okay, the tie line that we are looking at now, the S line, okay, it didn't goes until cementite. It just goes until this line. Dia punya line tu stop sampai kat sini. I think I should use a different color lah. Okay. So dia punya line sekarang dekat sini, sorry. And your R line is here, still the same. Your C naught is still here, 0.4, and the S value is from 0.4 until 0.77. Because here is actually 0.77. Okay. Right. Okay, so now it's still given 100 grams of austenite. Okay, the initial things. So you have austenite that forms alpha plus with perlite. Okay, so from here, maybe we want to identify what will be the amount of alpha and also the amount of perlite that is formed. So amount of alpha is known to be pro-eutectoid alpha lah, sebab dia memang close to the region of alpha, you have more alpha, then we call it as pro-eutectoid alpha. And another one is actually perlite. So I think I just want you guys to calculate a bit. Maybe can ask another person. Hui Chia apa ni? Hui Chia Chun. Chia Chun, are you there? Yes, no. Silent. Hui Kai Sian. Hui Kai Sian. Kashin?
Yeah, doctor, I'm here.
Okay, Kashin. I want you to calculate what will be the fraction, the weight fractions of pro-eutectoid alpha. Okay, based on this situation now, because as I said now, the composition that we are looking at is for pro-eutectoid alpha and also perlite. So please calculate what would be pro-eutectoid alpha. And another one, Sin Yong Ong. Sin Yong Ong, are you there?
Yes, doctor.
Okay, so can you actually calculate what would be the weight fractions of perlite that forms? Okay, so as I said, referring to this phase diagram, it is completely different with what we have seen just now. Okay, the n, that is actually the difference. So before this, we are just looking at the n until 6.7, but now I think the n is until 0.77 because the question just asked about formation of perlite and also pro-eutectoid ferrite. So perlite, as I said, it is actually equals to the composition of eutectoid at 0.77. So now the line stops here. It didn't goes until cementite. Okay. So, macam mana? Ui, question?
For the weight fraction for pro-eutectoid is S over R plus S.
Okay, yes.
So it's around 0.76 minus 0.4 divided by 0.77 because here you use 0.77.
Okay, 0.77.
0.77 minus 0.4 divided by 0.77 minus 0.022.
Okay, very good. Very good. And what should be the next? This is actually the fraction. So if you want to calculate the weight, what happened?
Multiply by 100.
Okay, good. 100 grams, because the question is actually asking 100 grams. But if the question changed to different amount, you should multiply with different amount, not only 100 grams. Okay, so we'll get this value. So same. How about the weight fraction of cementite? Sorry, not cementite. Oh, sorry. Perlite. Yes. Are you done?
Not yet. What? Give me a second.
Okay. It's okay if you have not calculate. You just tell me what's the value that you should use. Okay. So earlier, Kashan have mentioned that if you want to calculate pro-eutectoid alpha, we are referring to the S value. So S over R plus S. So the S value now is actually 0.77 minus with 0.4 because This is actually the region that we are looking at now, 0.77 minus with 0.4. 0.4 is the initial or the composition initial that we put in this question, 0.4% of carbon, okay, divided by the total length, 0.77 minus with 0.022, and finally multiply with 100. So what about polite?
R over R plus S.
Okay, R over R plus S. So what is R?
0.4 minus 0.022
Okay, minus
over
0.
0.77 minus 0.22.
Very good. Okay, and what else? This is actually the fraction. If you want to calculate the mass,
0.545
okay, then you multiply with 100 lah,
times 100.
100 grams.
100 grams.
Okay, so you get the answer. Actually, Yong On, if you want to calculate, I think the fraction of polite, since earlier, your friend, Kashan have calculate the values for you. So you can also use 1 minus pro-eutectoid alpha or alpha, 1 minus alpha to get the fraction, weight fraction of polite. So not necessarily have to be this one. So that is why I think quickly I just ask you what's the value. Okay.
Yeah.
So
Okay.
that's also the another option. Okay. But if you also, I mean, right, this answer also is not really a problem. It's still acceptable, and you can answer it. Okay. So this is actually the explanation just now, how you can calculate the amount of polite and also the amount of pro-eutectoid alpha in this case. All right. Okay. So I guess maybe before we end our lecture, let's just go through a few definitions of phase diagram reaction. So earlier in eutectic reaction, we have known that eutectic means that a liquid that transforms into two solid. For the case of lead tin, you will have like liquid double head arrow forming alpha plus beta. Okay, eutectoid, normally you will see a lot in cast iron phase diagram or even in other phase diagram. Eutectoid actually defined as one solid, okay, that transforms into another two solids. Okay, so if in the case of cast iron phase diagram, we'll see that the reaction will be gamma or austenite, double head arrow forming alpha of ferrite plus with Fe3C, which is actually the cementite. And the cementite can also be identified as intermetallic compound. So why actually cementite can be identified as intermetallic compound as well? So remember that in the definition of intermetallic compound that I've told you earlier, okay, it means that intermetallic compound normally forms if you have a phase that forms, okay, in the in the vertical line. So like this one, you have magnesium lead, Mg2 lead that forms in the horizontal line. In the case of cementite, you will see that cementite actually forms at around 0.7, and the line is actually vertical line. So this can be identified as well as intermetallic compound, right? And another terms that may be quite alien to you but need to be introduced is peritectic. Peritectic reaction. Peritectic reaction actually forms when you have liquid and one solid phase that transform into the second solid phase. So you have a mixture of liquid and solid that when it solidifies, it forms just one solid phase, a different solid phase. Okay. In this case, for cast iron phase diagram, you will see it being, let me show you. Okay. Yeah. So it will form somewhere here. So did you see a line over here? A vertical line, very small line over here. Nampak tak? Okay. So on top is actually delta plus liquid. And what will be the bottom? So kita nampak dekat bawah ni is actually austenite. Okay, sorry, austenite dekat sini. Okay, so the reaction for peritactic is actually gamma, not gamma, delta plus liquid double head arrow forms austenite. So this is actually the peritactic reaction. Okay, so you will see here. Okay, this is actually the reaction, peritactic reaction. And for a more complicated reaction, you will have eutectic, eutectoid, monotactic, peritactic, and peritactoid. So all this actually can be identified by just, I think, simply looking at any horizontal line that forms in the phase diagram, and you just see what will be the top and the bottom. Okay? So the trick is actually if you have a horizontal line and you have, I think, phase boundary of maybe liquidus. Kalau dia punya bentuk V tu dekat atas, so we are looking at the product, the reactant which is liquid, and the product is actually at the bottom. So liquid, and the product will be alpha plus beta. Eutectoid, okay, still horizontal line. The V-shaped boundary is on top. Then you will see the reactant will be gamma plus with alpha plus beta. So monotactic, is a different story. Monotactic, peritactic is also another story because the phase boundaries is located on the bottom. Nampak dia punya V tu dia dekat bawah pula, terbalik, inverted. So how actually you want to read the phase diagram is actually looking at this one lah. Okay. So this, yang ni pun sebenarnya dia tak betul ni. It should be alpha plus liquid forms beta. Okay. Yang ni pun apa tu? Dia akan jadi sepatutnya alpha plus beta forms gamma. Because you have peritactoid ni two solids that form one solid. Peritactic you have solid and liquid that forms another solid. Okay. So this is actually the definition. Yang ni reaction dia ni salah. It didn't reflects to the phase diagram that shown on the side. Okay. Right. So I guess maybe later on in your assignments, I will give a few examples and you can identify which one is actually eutectic, eutectoid, monotactic, peritactic, and also peritactoid. Okay. So this one, I guess maybe we will continue tomorrow. So far, any question? Ada soalan? Okay. So if no, then I will adjourn the class. I will share with you the attendance for today. Okay. And I will stay back for a couple of minutes if you have any question. But if you don't have, then I will adjourn the class. Thank you very much, guys, for your kind attention. Hope to see you tomorrow morning. And with that, Assalamualaikum warahmatullahi wabarakatuh. And thank you very much.